These are the video notes for our first lesson in vectors. These aren't actually the notes of how to do vectors. It's how to do your homework. We will have a second lesson on Monday where we will have guided notes and we'll go through them again. But I'm only making a video to show students who were out of class today how to get the homework done. So here we go. In the group of problems in 3 through 8, what you're going to be doing here is sketching on a piece of graph paper. We have our vector v and our vector u that are given here in the picture in the book. What you want to start with is find the components for those vectors. Then you're not going to need to look at the picture once you find the components. What you're going to do now is look at the problems here. You're going to be doing the odd problems. I'm just showing the evens. So problem number 4. This says the opposite of v. Negative v means the opposite of. Since v is 3, 4, what we want is to graph the vector negative 3, negative 4. Now remember, a vector is an arrow that shows movement, that we move negative 3 in the x direction and negative 4 in the y direction, but we do it in one smooth motion. So that's the vector negative 3, 4. Now, I drew this with the starting at 0, 0, and it doesn't have to. This vector that we have here can actually be anywhere we want. It's the same vector. It doesn't have to start at 0, 0. I could have started at any given point that I wanted to, so long as I went negative 3 in the x direction and negative 4 in the y direction to get to the ending part of the vector. So we have our initial point, and then we have the action, the force that acted upon it to get to negative 3, 4. Again, I'm not explaining a lot about vectors, I'm just doing some problems. We have u minus v, where we're going to take this vector here, and we're going to subtract vector v. So here I'm subtracting the components. We get a resulting vector of negative 5, negative 1, and I have graphed it in purple. To do 2u plus v, I double the u vector, and then I'm going to add the v vector. So I just add my components, my a's and my b's, and I get negative 1, 10, and graph that. Again, I do want to remind you that these vectors, while I drew all 3 of them where they started at 0, 0, I didn't have to. I could draw this vector anywhere I want. It's still a vector that moves negative 1 in the x direction and 10 in the y direction. For the next group of problems, you were to identify the vector in component form, the A, B format. In the graphing ones to do, you just look at it and examine how far do we go in the x and how far do we go in the y to get to that terminal point. And for this first one, we're seeing that we go negative 2 and negative 3, so therefore that is the vector in component form. For ones where we're given the 2 endpoints, the initial point being P and the ending point being Q, how did we move from this point to the other? Well, in the x direction, we went 8, and in the y direction, we went 8, so the vector in component form is 8, 8. For number 18, I go from negative 8 to 7, and negative 8 to negative 1, and that's a change in 7. From negative 6 to negative 1, that's a change of 5, so there's my vector. While they say A, comma, B, I do think of that as the change in x and the change in y. We're going to sketch these points, but starting at 4, 3, where this time I know specifically where we're supposed to start. So we take my graph paper and I identify the point 4, 3, and then I'm going to apply this vector, negative 1, 2, and show where we would end up when we do that motion. And the vector is just the arrow, not these little dashed lines. I'm just kind of showing how I found where the vector ends. And the vector has a beginning and an end with the arrow. And there's problem number 22 at negative 8, negative 1. For this next set, we have 3 different points, and we're going to apply the same vector to all 3 points. So in number 24, I'm going to apply the vector 4, negative 6, and there it is. It's where I changed 4 and then went down 6. Again, the motion was the arrow, but we can describe how we got to that endpoint with the vector. And I'm going to have the same vector for coming from 2, 3, and the same vector coming from negative 3, 5. As I was mentioning before, these vectors don't have to be in any given location unless they told us so. And they told us so in this problem, to use 0, 0, 2, 3, and negative 3, 5. But this vector that I'm moving around, it's the same vector. It's 4, negative 6. No matter where I put it, this is moving positive 4 in the x direction and negative 6 in the y direction. So just for randomness, I drew another one right over here. I'm not doing any other problems for this. This is the same idea that you're going to do the odd problems in this section. For these ones, you're going to be doing these different operations, and so I'm just showing that I would do actually 2 times. This is a scalar multiplication, so you just multiply the components by 2. Then the next thing we're going to do is a scalar multiplication to vector v, where we're going to multiply vector v times negative 3. So the components are multiplied by negative 3. Then we're going to add our 2 vectors where we add the components. We add negative 2 and 2. We add 5 and negative 8. And we end up with 0, negative 3. For this last one, for problem number 32, we are going to multiply vector u by 3 and vector v by 4 and then subtract. So I multiplied each of them, and then I'm going to subtract, and I'm going to subtract negative 6 minus 8, and I get negative 14. I'm going to subtract 15 minus negative 32, which means 15 plus 32, and we get 47. And you're going to do the same idea with the odd problems that were assigned. Okay, the next group, we've got quite a few things to do here. This is about magnitude. Remember, magnitude was basically the idea is distance, or the length of the arrow. So we're going to use the components, and the components for number 38, for the vector u, the components are negative 2 and 3, and the components of v are 1 and negative 2. So I write the components down. To find the magnitude of u, I use that. I square the negative 2, I square the 3, and then I add them and take the square root, and I get the square root of 13. For the magnitude of v, I square 1, I square negative 2, add them together, and I get square root of 5. So now I have the magnitudes of each of those. In this next one, I want the magnitude of 2 times u, 2 times the vector u. But that's the same thing. We can actually factor out a scalar from the magnitude. So we can say it's 2 times the magnitude. So we don't have to do the magnitude of twice the vector. We can do 2 times the magnitude we already have, square root 13, which is just 2 root 13. We're going to do the same thing with vector v, except we're going to multiply it by 1/2. So remember, we're just going to take this magnitude we already have and multiply it by 1/2. And I get 1/2 root 5. I just like writing it root 5 over 2 this way instead of 1/2 root 5. For the next 3 problems, it's really talking about how there's a difference between adding 2 vectors and then finding the magnitude, or in this case here, subtracting 2 vectors and finding the magnitude versus subtracting the magnitudes. So for the first one we're adding, we add the 2 vectors and get the resulting component of negative 1, 1. And we use the squaring and adding and take the square root, we get square root of 2. We're going to subtract our 2 vectors first to find our component, and then we're going to find the magnitude, which is negative 3 squared plus 5 squared, take the square root. So when we subtract the 2 vectors and then find the magnitude of that, we get square root of 34. But when we say subtract the 2 magnitudes, well, we have those magnitudes, root 13 and root 5, and we get root 13 minus root 5. And this is not the same thing as the square root of 34. When we're given the magnitude and the direction, which is going to be in an angle, positive degrees, we are going to use the conversion just like we did in polar. In polar, we said x is equal to r cos theta. And in vectors, a is it's not the same thing as x. It's actually the change in x, but it's the x direction. And magnitude is very similar to the r in polar. It's a distance. And then we have cosine of our direction. So for this problem, we're going to do 50 times cosine of 120 to find our a, and that's negative 25. We should know the cosine of 120 because we've memorized our trig in the unit circle. 50 times sine of 120 is 50 times root 3 over 2, which gives us 25 root 3. Now this is the way using this formula, but we should note that the angle 120 is on the unit circle. So if you're given a direction that's one of the 16 memorized angles of a unit circle, we have another way we can approach this problem. And that is, we can just write the magnitude times the point on the unit circle. So for 120 degrees, that point is negative 1/2 root 3 over 2. Distributing our 50 in there and then writing it with the pointed vector brackets, we end up with the exact same result. And you could do this either way. We have to use this formula when the angles are not one of the 16 known angles. If I gave you like 17 degrees, you would have to do the magnitude times cosine of 17 and use a calculator and get a decimal approximation. For these last group of problems, you should find the magnitude, which is to square each of the components, add it together, and take the square root. So for problem number 48, when you square each of those, you get 2/4. Add that together, you get 1. The square root of 1 is just 1, and that is the magnitude. To find the angle, now the formula is arctangent of b over a, just like it was when we did polar, when we were trying to find an angle, and we did y over x. So this is b over a. And we look at this and we say, oh, that happens to be in quadrant 3, where my x and my y are the same value. That's 225 degrees. But we can also think of this as what angle in the unit circle has the coordinate point negative root 2 over 2 comma negative root 2 over 2, and that is, again, 225 degrees. For problem 52, my components are 1 and 1. So the magnitude for that is going to be root 2, because you go 1 squared plus 1 squared is 2. Take the square root. To find the angle, well, I'm thinking this is quadrant 1 because it's positive, positive, and my x and my y, or my a and my b, are the same value. So what angle has x and y exactly the same? Well, that would be 45 degrees. So these are just examples of problems like you have in your homework.